welcome to the channel. So in today's video I want to talk about k-fold cross validation using Scikit-Learn. So this particular technique is a model evaluation technique in machine learning. Usually what we do is that we split the data set into train and test set, or I should say a fixed train and a fixed test set, and in that case the model actually do not get evaluated on the whole of the data set, but using the k-fold cross validation we can run multiple iterations on the whole dataset and use certain part of the dataset as test in different iterations. So let's type coding. So let's type some code and we'll understand it better with coding. So as usual, I want to import the required libraries. So let's import numpy as np, then import pandas as pd from sklearn preprocessing import train test split, sorry, not train test split, it's label encoder, and from sklearn dot model selection import train test split. Then from sklearn import svm. Finally from sklearn dot naive base import categorical naive base. Okay, so these are my required libraries for this example. Now let's load the dataset. So it's called car evaluation dataset. So pd.read csv, sorry, forgot to mention the csv part. Okay, so this is our dataset. Let's check the shape. So 1728 rows and 7 columns. The last one is obviously the target column. Let's check df info. Okay, so dtype is showing object, so that means all of the columns are categorical columns, but I see 2 in these 2 columns, but why are these categorical? Let's check the unique entities in these 2 columns. So df.doors.unique, and also let's check the value counts. Okay, so the reason why these are treated as categorical values is because they are being shown as strings. So we can see the quotation symbol here. Okay, so I think that's the case with the other column as well. So the next one is persons. So let's change this. Okay, so we have 2, 4 or more. So these are also strings. So we need to change them into integers. So let's perform preprocessing. So let's create a dictionary. So we have 2 within quotation. We'll remove the quotation for 3 as well. Then 4. And lastly 5 more. I will just call it 5. Okay, then doors dot apply lambda x to strict x. Similarly for the other column as well. So this is a persons column, person strict. So I think we do not have 3 here. We have 2, 4 and we have more. I'll replace more with 5. And here so the person. Okay, let's just change this name. Sorry, double comma. Okay, so now let's check these two. Okay, so copy this line. So instead of 2, 3, 4, 5 more inside quotations, we do not see any quotations anymore, but these values are same. Okay, similarly we can check this one as well. Again we only see 2, 4 and 5 because I replaced more with 5, and these are also same. Okay, and we can also check df.info. So now columns 2 and 3 have been replaced with integer 64. Previously they were object here. So but we need to take the other 4 columns, take care of the other 4 columns. So buying, maintenance, sorry, 5 columns including the target. So luggage space and safety feature. So in that way, before that I think we can also check the unique values in the target. So div class okay, so there are 4 types of values in the target column: unacceptable, acceptable, very good and good. So these are showing car conditions, I guess, and unacceptable is present 1210 times, others significantly lower. Okay, so now let's take care of the rest of the categorical features. So I for I in df dot columns. Okay, did we select the 5 object column buying, maintenance, luggage, food, safety class? Yes. So now for j in dfj dfj. Okay, so we do not see this v high, small, low, unacceptable anymore. We see 3 to different integers instead of these categorical values here. Okay, so I think we have processed the dataset, and just for clarification, I think we can run this once more. So now instead of unacceptable, acceptable, very good, and good, we have 2031. Okay, so now we can just separate features and classes. So df.iloc and y df.iloc. Okay, then we can split. So xtrain, xtest, ytrain, ytest. So train test split. So we provide x, y, test size 0.25, train size 0.75, and random state 42. Let's also check the length of xtrain. Okay, so after this train test splitting, we got 1296 samples in the train set and 432 samples in the test set. So then we can apply, let's say, support vector machine as a machine learning model. So svm.svc. So let's select a linear kernel, and c is 2 and random state 42. So by default c is 1, I selected 2, and kernel is rbf, but I selected linear. Then we can just call the fit method. So xtrain and ytrain. So this is the usual approach. Then after that we can check the accuracy using model.score. So xtest, ytest. Okay, so after using train test split, we are getting a test accuracy of 70%. So in this way, we are selecting 1296 samples for train set and 436 samples for the test set. after a 25% and 75% test and train is split. And because of this random seed, the same 432 samples are selected again and again. No matter how many times we run this cell, the same 432 samples will be selected for the test set. So this approach sometimes leads to a high variance, and depending on the random state, actually the performance can vary. So if we select a different random state, this may be high or low, something like that. But k-fold cross validation actually allows us to select all the samples in the dataset as test set in multiple iterations. So the test set in that case is not fixed, neither the training set. So let's see how that can be done. So let's say k-fold cross validation using sklearn's cross-val score. So this is a shortcut way using the cross-val score function that sklearn provides. So we can just use this function. So forgot to import this function. So cross-val score, and we also need few more. Okay, cross-val score. So here we provide our model, which is this model. We provide the features, classes, and let's say I want to use 12-fold cross validation, and scoring will be accuracy. Okay, now so 12-fold means that we have a total of 1728 samples. So they will be divided in 12 partitions, and one of those partitions will be used as test and other 11 will be used as train. And in each iteration, so in each fold the test set will change. So let's say if in the first fold, if the first partition is used as test, in the second iteration the second fold will be used as test, then in the next the third fold and other 11 will be used as train set. So in that way it will continue. So let's print the accuracy in each fold. Okay, let's print accuracy for fold. Okay, so let's print. Okay, so in the first fold we got an accuracy of 70%, then 68%, and other accuracies are shown for the remaining folds. Now what we do is we take the mean accuracy on all the folds. So scores.mean. Okay, so the mean accuracy after applying k-fold cross validation using this method, cross value score, we got an accuracy of 73%. But when we used this method, train test split, with this random state, the test set and train set was fixed, and it gave us an accuracy of 70% or 70.6%. So we can say in this case, when the model is evaluated on the whole data set using different train and test splits, we got a mean accuracy of 73%. So in this case, the generalization is slightly better than this case. Okay, so this is actually the shortcut way of doing it. We can also do it in a hard way, so that's how it works. So I will just copy this one. So k-fold cross validation using Scikit-Learn's k-fold. So kf k-fold in splits 12. So same as this one. Okay, then let's create a list, and another variable is k, which we listed from 1. Then for train index, test index in kf dot split xy, so features and classes, xtrain, xtest, train index, y, train index. Similarly, y train, y test will be y, sorry, this is test index. So not y, this is x. Okay, now it looks okay. Then just copy paste. So this will be now k. This will be round model dot score, xtest, y test. Okay, then we will append the accuracy of each fold to our list. Then we increment k. Let's type it. Okay, something is wrong. None of index are in columns. Sorry, I have to mention x.values here. should work now. Okay, now it's working. So here we can see the accuracy for fold on is 89%. We can also see the accuracy for other folds, and I think this is the lowest. So this actually varies a lot, like lowest accuracy is 55%, but highest is 89.58%. Okay, so this splitting is not working very well compared to this one. Here we got, I think, lowest of 68%, I guess, and highest probably 77.78%. So this is more robust compared to this one. But anyway, let's check the mean accuracy. So scores list. Okay, so the mean accuracy is 71% after using k-fold for splitting, and this is, I think, is still higher than this one. Okay, but as I said, this is the shortcut approach of this. So here we typed like how many lines, 1 2 3 4 5 6 9 lines, but here we did the job using one line, and here I just printed using a for loop the accuracies. So we can actually just copy these, then paste. Instead of 12 we will use kf, this split, and I think everything else remains same. Then take the mean. So now you see this score and this score is same. So we do not actually need to type all these lines. You can do that obviously if you want, but it's not necessary. We can use this shortcut approach. Okay, and there is another option which is called stratified k-fold. So let's call it stratified k-fold, and this will be 9, I think. So let's call it skf, stratified k-fold, n splits 12. Then I'm not gonna type these lines again, just copy and paste. So I just want to rename this part because I will need it later, and this will be skf. Okay, so now previously we saw 89% for fold on, now we see 70, 68, 88. Okay, I think these values are looking similar to this one. I think let's check the I think just copy this line, and this will be scores list 2. 73%. Was it the same? Yes, 73%. So we can confirm it using this shortcut approach. So here this will be just skf instead of kf. Yes, we got the same outcome. So that means by default this cross value score method actually uses stratified k-fold. So the difference between this stratified k-fold and k-fold is uh, this option actually takes care of the class imbalance issue. So if you look at our classes, it's not balanced because this is very high, this is very low. So k-fold does not address that problem. That's why we can see that like lowest accuracy across a fold, not a fold, more than one fold. So this one as well is 55 and highest is 89. But here we can see lowest is probably 68 and highest is 77. So less variation here compared to these ones, I guess. So by default, this cross-value score is using a stratified k-fold option. We can confirm it if we just replace this with 12, which we already did, I think, here. So we should get this square. Yes, we are getting the same score. So on last thing, let's apply another model, which is, let's say, categorical naive Bayes. So let's just instantiate it, then copy paste as usual. So here instead of model, we'll use CLF, and let's see how much score is this giving us. So it's giving us 77%. So we got 73% by using k-fold cross validation on this ASBM model with these particular parameters. So kernel linear C2 randomized this, and I didn't change anything here. So with these default parameters, we got 77%, so which is 4% more than SBM. So with this current setup of SBM using linear kernel and C is equal to 2, we can say that categorical naive Bayes is providing higher accuracy than support vector machine. Okay, so let's say if we have to select either this model or this model, then after cross validation we have seen that this is giving us better results. So this is more robust than this one. So we'll obviously select categorical naive Bayes instead of support vector machine with these settings. Obviously if you change like kernel, so there are different options. Let's say, so there are linear, poly, RPF, sigmoid, etc. You may get better results for SBM than categorical naive Bayes, but I'm not going that far in this video. So if we have two models, let's say categorical naive Bayes and SBM with these settings, for this dataset called car evaluation, then our option is very simple. We'll use categorical naive Bayes. It generalizes better by giving a higher score on all the folds. So I use 12 folds. So this is how k-fold cross validation is actually gives us a better estimate of a model's performance by evaluating it on the whole data set and by using different trained set and different test set in multiple iterations. So that's the end of this video. Thanks for watching.